Hi, I'm 𝗦𝗬𝗀𝗀𝗀𝗁𝗀, Principal Developer Advocate here at Progress Software and 10-time Microsoft MVP. And today I'll be giving you an introduction to retrieval augmented generation. Over the next few minutes, we'll talk about why you should use RAG, how retrieval augmented generation compares to context augmented generation, and the key concepts involved in RAG. I'll also share an introduction to Progress Agentic RAG, a RAG as a service platform. First, let's start with why retrieval augmented generation is important today. Using retrieval augmented generation is all about making sense of your data. I gave a session back at the M3 conference in 2016 where I talked about the future of data storage and how it relates to machine learning. In that session, it was estimated that 44 zettabytes would have been collected by the year 2020. Here we are in 2026, and we are generating and collecting roughly 400 million terabytes of data every day worldwide. That's about 0.4 zettabytes a day, or 147 zettabytes per year. So why does that matter? Well, we need to make sense of all that data we collect. And back in 2016, my suggestion for doing this was to use machine learning. The reason for that is really simple. It's not humanly possible to make use of all that data we collect without using some sort of AI. Today, machine learning is a commodity in the form of large language models, and the task of sifting through data for answers can be performed by human operators assisted by agentic systems. Before we can talk about retrieval augmented generation, it's important to talk about context augmented generation. These core concepts will help you understand the scale of the technologies and architectures involved. Context augmented generation is where we add data to the context window of a large language model. For example, we might take a file and upload it into the context window so we can ask questions about the data contained in that file. An example of this can be seen on YouTube. There's a Gemini button on some YouTube videos, and when you click on that button, the transcript of that video is loaded into the context window of the large language model. That allows you to query the video conversationally. Another form of context augmented generation is cache augmented generation. This involves taking even more data and storing it in vector memory. You can then search through that memory structure, pull out pertinent pieces of information and data, and insert those into the context of the large language model. An example of this can be seen inside of Copilot within Visual Studio Code. Your agent has memory of conversation. Your project files are also loaded into memory as vector data for quick semantic searching. And the large language model has access to all of this data in its context. When you ask it to perform coding activities, it can reach into its cache, retrieve pertinent pieces of data, and use those to generate code, answer questions, create summaries, and so much more. Retrieval augmented generation is another form of context augmented generation. This time, it's using a vector database to store and retrieve information from large volumes using semantic similarity. The retrieval portion of retrieval augmented generation is all about finding useful information through vector search. This is different from traditional keyword search. Instead of searching for exact keywords, we use AI to search for content with semantic similar meaning. Once we find that information, we retrieve it from the vector database and place it into the context window of the large language model. We then ask the large language model to generate a new response using that information. We can also ask it to create citations so users can trace where the information originated. Citations are an important feature for tracing answers back to their origin and providing that the answer is grounded in real knowledge. In other words, the system can show receipts that prove the answer was not hallucinated. When we work with retrieval augmented generation, we use vector databases to store large amounts of data. We do this by ingesting resources and passing them through a vector embedding model. That embedding model extracts the meaning from the text so we can perform searches using semantic similarity. If a document is large enough, we may need to chunk that document into smaller bite-sized pieces. That makes it easier to ingest and store inside of the vector database. Because RAG can store large volumes of data, it's perfect for generative AI search. Generative AI search empowers users by allowing them to use natural language to query large datasets without memorizing specific query syntax. It also helps make sense of large volumes of business data stored in unstructured formats, such as websites, PDFs, images, videos, and many other resources. And it does this all while querying them as if they were coming from a relational database, thanks to AI. An end-to-end RAG architecture is actually pretty complex. It requires multiple system components that are often sourced from multiple vendors. For example, you'll need a user interface, you'll need embedding and chat models, you'll need to have a data strategy, and document providers for all of the documents I talked about, whether it's PDF, Office files, video, images, etc. You'll need a provider to translate those types of documents into text so they can be embedded into the vector database. And then, of course, you'll want to evaluate the quality of the data coming in and out of your RAG system. This requires a lot of expertise to glue together all of these different pieces, and the expertise involved is software engineering, data science, and AI experts. It's very difficult to scale, and it's also difficult to predict cost. Some of these concerns were cited in a recent article by VentureBeat, where they suggested that enterprises are transitioning away of their current RAG stacks. These were RAG systems that were built in-house and didn't have the fundamental knowledge of agentic retrieval augmented generation, where agents help re-rank search results and evaluate system metrics as data is ingested and retrieved. For a complete end-to-end solution that solves all of these problems for you is Progress Agentic RAG. Progress Agentic RAG is a RAG as a service platform that can ingest all sorts of documents, whether it's video, audio, chat logs, or other information. Document providers are already there in place for you to ingest data. It makes sense of structured and unstructured data, and there's agents within the system that can extract key text, tags, entities, and generate embeddings, all with large language models. It has a hybrid search feature that includes keyword search, semantic search, and graph search, and all of that is re-ranked by an agent. It also has an embedded quality and evaluation metric known as ReMi. This is an AI agent that evaluates the system's stability as data is ingested and retrieved. And all of Progress Agentic RAG can be managed through an easy-to-use user interface that a system administrator can log into to ingest and manage data, orchestrate AI agents, and check evaluation metrics. For projects that require a quick turnaround time, administrators can use an HTML widget builder to create robust search experiences that also include citation and retrieval. For more complex scenarios, such as building custom agents, custom user interfaces, or complete application architectures, SDKs for .NET, TypeScript, and JavaScript, and Python are available, as well as REST APIs. Let's take a look at a customization scenario and see how this would work with .NET and Blazor. For this demo, we're going to create a business dashboard using Progress Agentic RAG and Blazor Server and connect them using the C# SDK. The financial dashboard that we're going to create will ingest PDF financial statements and extract pertinent information from those PDFs so we can generate visualizations such as charts and graphs and also have conversations with the AI regarding the data in those PDFs. The first step is to log into our Progress Agentic RAG system, and once we log in, we're greeted with our Progress Agentic RAG dashboard. From here, we can see metrics on quality, storage, and the last resources that were ingested. From the Upload tab, we can upload new resources in the form of files, folders, links, text resources, entire sitemaps, and Q&A resources. The file resources can be any Office type, they can be videos, images, and audio files like MP3s. I've already ingested some resources here and I can see them in my resource list, and I have some reports from some of the big companies of the world. We have Amazon, Apple, and so on. So if I look at Apple's SEC filings, I can see that I have a resource here in my file field, and this is the entire SEC filing in PDF form that's been ingested into the Progress Agentic RAG system. I also have some generated fields, and these fields are data that has been extracted from the PDF using AI agents that are running on the data in the background. Those AI agents are configured in our agent screen within the Progress Agentic RAG system, and you can test and evaluate those agents within the UI here. This agent in particular has been configured to extract chart-friendly data from the unstructured files that are being ingested into the system. This is a step that helps the retrieval agent find the data that we're looking for when we start providing structured data types to the system as queries. Once I've ingested data into the system, I have a simple search window that I can come in and use to check my data that has been ingested. So for example, I can ask questions about what was Apple revenue, and I'll get a response from the system that Apple's total net sales from 2024 were $391 million. This simple search can be converted into a widget by hitting Create Widget, and then I can quickly deploy that widget to a web page using some HTML snippets. For something more advanced, I'm going to use the C# SDK. So I'm going to go into Visual Studio now and look at an application that uses the C# SDK alongside Blazor server to produce a completely custom user interface. To quickly retrieve an answer from Progress Agentic RAG within the SDK, I can call upon the search interface and use the ask async method. With the ask async method, I have the option to supply a structure that I would like the Progress Agentic RAG system to fulfill. This is just a plain class object. This one is called chart augmented answer, and I'm going to pass that type along with the user's request. And when the type is passed into the system, this chart augmented answer gets turned into a JSON structure. That JSON structure is then seen by the retrieval agent, and the retrieval agent will map the values from the search results into the JSON structure and fulfill all of the properties that we ask for. That gets serialized back into that chart augmented answer object within our application, and then I can easily display that information on the screen to the user in the form of text and charts. Now the application is running in the browser, and I have a completely customized user interface that was built using the Telerik UI for Blazor component library and is all backed by the Progress Agentic RAG C# SDK. In my chat interface, I have some suggestions here, so I can compare NVIDIA and Google's revenue at the click of a button, or I could enter a query just using natural language. So when I compare NVIDIA to Google, you can see that I get a detailed comparison in text, but I also have a chart that I can open. And when I open the chart, that structured data that I asked for from Progress Agentic RAG is relayed back to my Blazor application, so it can be easily passed off to some UI components for rendering chart data. This just shows the depth of how custom you can go with Progress Agentic RAG and the SDKs available and whatever front-end technology that you like to use. For more information about Progress Agentic RAG, visit progress.com, and you can also use the QR code shown on screen to gather all of the resources that were found in this presentation, including the financial services application that uses the C# SDK in Blazor. Thank you for joining me, and I hope you learned something about retrieval augmented generation. Enjoy the rest of Build.